Welcome to our live stream from Embedded World 2023 in Nuremberg. We're welcoming you back, and I've got here with me Joe and Thomas. Hi both, how are you enjoying Embedded World?
It's been a busy show, my feet are sore.
Okay, so we're going to talk about something really interesting. We're going to talk about a digital badge, which is based on ExpressLink. But first of all, can you both introduce each other briefly?
Sure. I'm Joe Julisher. I'm a senior software development engineer on the FreeRTOS kernel team. And also I'm the senior engineer who's works with the making the ExpressLink, which is the module at the top of our badge.
And I'm Thomas Kriechbaumer. I'm a senior IoT specialist solution architect. Recently moved over from our mobility startup team. So as a solution architect, of course, I'm directly helping our customers to build the products and their solutions using our AWS technology.
Very nice, thank you very much. So I'm just going to shoot some questions, so feel free to take turns and answer or do whatever you like. But I think our developers would like to know, what are the challenges in building a connected product? So why is it so difficult? Why did you have to build this lovely prototype?
All right, so my background is primarily embedded. So I look at challenges a little bit differently than perhaps Thomas's challenges. So we actually complemented each other very well on this particular project. So as an embedded developer, I was used to C programming and basic connectivity, but the cloud is a bit of a mystery. So the idea of making such a device, actually, I was very comfortable with. I knew it was going to take a couple of prototypes. I knew that not everything was going to work out correctly. Like, this is our first prototype, and it's got plenty of modifications done to make it work. But it's a pretty straightforward process to work through those kinds of things. But when the data disappears into the cloud, that was kind of a different kind of concept for me. So I had to do a lot of learning on the IoT cloud side, much more than I had to do the hardware.
And for me, it's kind of from the other direction, right? I'm a traditional software engineer, cloud person. I'm comfortable with AWS infrastructure, writing CloudFormation, automation, infrastructure code. So the embedded world is kind of the little bit of mystery, kind of how do I get actually the data into my cloud? How do I program my devices, and how do I make it play to my will? How do I make changes to my devices? And I think that's kind of the real challenge that we were trying to solve now with ExpressLink and building such a first device to bring those two schools of thought together. How do we make cloud infrastructure, databases, storage, compute, and how do we marry that together with the embedded world, building a device, manufacturing a device, sourcing components, and solving all of those challenges in between.
Right, yeah, that makes sense. I mean, I come from software engineering myself, so the embedded world is actually also relatively new to me, I would say, so I totally get it. What I find interesting about this different, prototype versions is that it really gets smaller and leaner, It's like you've got here probably the initial one, right?
Yeah, this was the initial one. And one thing I've learned making a lot of hardware over my career is don't try to shrink it to the final form factor. You are going to make a second spin, guaranteed. So make the first one easy to work with. Now, we did kind of make it a little bit product-like, but we didn't try really hard. And we left plenty of room to be able to make measurements, make adjustments. You'll see that there's some connection wires on here. So there were some mistakes. The biggest one is the screen is aimed down, because it turns out the footprint we had for the screen was exactly inverted. So we were able to use it, but it meant that our screen hung down instead of upright. Like you'll see on the final one, the connector is on the bottom, and then it makes the screen come up. And that was what was intended, but it doesn't always work out on the prototypes. Fortunately, we were able to make it work, and this did run the final software. It just wasn't in the final appearance. But there's always time. Once you have the electronics working, going back through to pretty it up, make the hardware have your message, contain your message, and to have the parts aligned just right. Making sure, like, we were featuring ExpressLink, we put it top and center. Things like that were very important, but don't try to do that up front. Come in on that after it's working.
Okay. All right. So for the viewers out there who are not familiar with the badge project and with ExpressLink, could you tell us all what is the badge and what does it do and why you built it?
Yeah, of course. So the whole idea came out of that we launched AWS IoT ExpressLink mid last year into general availability as a new AWS offering. And with all of our AWS products and services and features, we want to educate our customers. the best feature is the one that gets used by a lot of people. And to, well, send the message, spread the word about those awesome new toys that we have built, we need to build a workshop. We need to educate our people, our customers, also internally as well as externally, and show them the capabilities that we can do. And at AWS, we always have an annual conference, reInvent, right? It's in Las Vegas, huge amount of people, mostly cloud engineers, but more and more IoT engineers are also joining nowadays. And that was the perfect opportunity for us to come up with an interesting and fun project to bring the IoT ExpressLink service and marry that together with a device that people can play with. So we need a device itself, which we now have in the form of our demo badge device, but we also need the workshop to have some training material, step-by-step instructions, and how do we communicate that best, right? ExpressLink itself has many interesting features. So we really split it apart into the device itself, and then also the workshop, the training material that we can then share and make public so other people can benefit from that and work through those materials.
So rolling back a little bit, the ExpressLink device itself is just this little module on top, and we don't make that. What we do make is a specification of what comprises an ExpressLink, and that specification describes a secure device that has been penetration tested. It has specific hardware security features, and it has a specific interface, an AT command set over a UART interface, so that your host processor, in this case we used a Raspberry Pi RP2040 running CircuitPython, that host interface can be my secret sauce, the application that I understand how to write. If I'm in some other area that's not necessarily IoT, but then I can communicate with the module through these AT commands that just connect. And that connection isn't a connection to the internet. It's a connection all the way to AWS IoT services. And so that takes a lot of the headache out of the connection, the security, the issues that as an embedded engineer I might not be familiar with. But I am familiar with my application. I am familiar with how to send messaging, and that module takes care of it. So these modules are provided by a number of partner vendors. This particular one, we had to pick one. So this particular one is made by Espressive, but it has the same interface as all of the other vendors that are on board with making a product.
Yeah, thanks so much for actually covering the benefits of using ExpressLink, because I think this is really important for our viewers. What I also want to mention is that we're going to have Joe and Thomas again tomorrow and the day after tomorrow to continue the conversation about the badge. So this today is just an introduction, right? So how did you come up with the idea? Like, why is it a badge of all things,
So at all the IT or computer or even academic conferences, a badge is always something very special, right? Sometimes it has your picture on it, it has definitely your name on it, so it's a personalized item. And well, IT people, hardware people, we like to tinker with things. Have something around your neck that you can wear, that you can show off, and customize. And that's really the key idea behind the badge, right? You can wear it on the lanyard around your neck. You have a display, you can show your picture, you can show a QR code with your contact details. You can show a hello world message if you want. Or you can also send a message to some other people and show it wirelessly. And then, of course, well, it's a device. We need to demonstrate something. It's a nice form factor. It fits into the palm of your hand. It's very easy to use. You can plug in a USB cable from the side. So it's all nice and easy to use. Doesn't take up a lot of bench space or real estate, basically. It's an easy to use device, nice and compact, and it has all the parts that you actually need to learn and develop with ExpressLink, right? You don't need 3 different other cables or 7 other adapters and integration plugs. Everything you need is in there. It's just a USB cable. You can write the code directly on the badge. You don't need to compile it or flash it. It shows up as a flash drive, as a USB flash drive. Plug it in, type your Python code, click save, and you're done.
Wow. Awesome. I mean, I'm sure our viewers are wondering how they can get their hands on this magical, wonderful device.
Come to reInvent this next year. We're making another badge, we hope. So if we're able to get time and get the class into place, then there'll be a new badge for this next session.
Okay, all right. Well, now moving on to more serious things, right? So let's talk a bit about the challenges. What are the challenges that developers are facing when building prototypes? I mean, you guys have done this a lot, so you know the ins and outs. What are the biggest challenges?
So the first thing that Joe already mentioned is the firmware, and that in our case we are running CircuitPython. And that makes it a lot easier for beginners, for starters that are not familiar with the embedded world, to just write Python code. Python is, I think, one of the most popular languages nowadays, especially in the cloud environment. Super easy to use, has a very clean and readable syntax, and you can get started with just 3 lines of code, right? If you would compare it against your, let's say, traditional embedded C development, well, you have all sorts of tool chain and compilers and flashing tools. You can spend the whole day setting up that whole tool chain and setup. With CircuitPython or with any Python-based system, it's a Python file. Drag and drop it onto that flash drive that shows up when you plug in, and you can run your code within seconds without any tool chain.
So one of the challenges of a badge or a training hardware, which is kind of unique to other kinds of hardware, is that we have a classroom mission that we have to keep in mind. And the classroom mission starts with getting the person up and running. So that's why we chose CircuitPython, for the reasons Thomas mentioned. Having a clean message on the badge, so it's not cluttered. We're not going to be putting this in an enclosure, so the board has to be pretty. It has to show the messages. We have messaging on the back that has where the I/O is, so a new person can just read the messaging and go to their Python and see exactly how it should work. So there's a lot of those kinds of factors, and you can see that in the evolution of the badge from this big, ugly green one to this one. Little things like the lanyard clips or horizontal. Then we decided, well, maybe it look a little bit nicer if we made the lanyard clips at a slight angle. So the little touches do matter. One of the things that we had challenges this last year, though, was getting components. We spent a lot of time debating about, should we use this Raspberry Pi device or should we use some other device? And this one was almost the best choice, just because we could readily buy the 500 units that we needed to make the badges in the quantities required. Some of the parts had many months of lead time.
Yeah, and it can developers, for example, let's imagine developers not familiar with Python. Can they run anything else?
Of course.
Like JavaScript, even
maybe not
C?
JavaScript.
No.
So this board is from the Raspberry Pi Foundation, and it does support other programming environments. Mm-hmm. The one that they primarily support is C, okay. And they have a very easy to use CMake-based build system. And there's good support. There's also an Arduino environment for this particular module. And I believe there's a WebAssembly and a couple other environments. But the CircuitPython was the best fit for the class that we were presenting, because there would be 0 tool chain setup for our participants.
So in general, it always depends on the manufacturer of the chip itself. If you have an NXP or ST or whatever microcontroller, a lot of it is managed then by the open source community, right? Those are the enthusiasts that really drive forward the acceptance of those chips. So you can definitely find open source projects that run Rust on one of the RP2040 chips, or Golang as TinyGo, or MicroPython and CircuitPython as Python interpreters. So there are a lot of different varieties that are, some are more on the educational spectrum, and the others are more on the production spectrum, where we then go into the C environment.
But then you have other challenges. For example, we definitely wanted to exercise this accelerometer. There's an NFC component, the display. And we were focusing on getting all this put together. We did not have time to write new drivers for Golang for all of these components. So we picked CircuitPython also because every component on here already had a driver. We did not have to spend our time creating drivers and making sure that they were debugged and ready to run. We determined on our very first prototype that everything was ready to go. It was just going to be a packaging and the class material issue, and then making sure that the cloud side was ready to carry the messages and the training that the board could deliver.
I see, okay. So interesting that you mentioned the cloud side. What is the cloud side of this solution, this badge?
So the hardware can support just basic MQTT messaging, which is also very interesting. However, it also supports curating some AWS services, such as OTA, over-the-air updates. So we made an application that would use over-the-air updates. Rather than updating the firmware of the host processor, it would update the image on the display. So you could, in fact, here at the show, we're showing people that they can take their picture with their cell phone, encrypt that picture using a QR code that will exchange a certificate between the badge and their cell phone via the camera, and then I'll upload through the cloud and then download directly onto the display. Another feature is shadow, and this board has a number of sensors. The accelerometer allows it to know its orientation. That data can be reported live to the cloud. where it can be updating a live database. We call it a shadow database that represents the current state of the board. Then we have another application, a cloud-based JavaScript, that collects all that information out of that shadow as it's updated live, and then shows the physical condition of the board. When the LEDs light up, within milliseconds, the LED on the dashboard lights up. When you rotate the display, it rotates live with you. When you put a picture on the screen, there's a picture that shows up on the model. So it's like a digital twinning technology. You can see exactly the state of the hardware.
And that's even bi-directional. So you can change the LED color from your browser page, and within seconds it syncs it down to your device, and you see the device flip over, and suddenly your color is green or red or whatever you have selected on the browser tab.
Wow. Yeah, that's really interesting. So this means that if developers want to get access to this and want to see your workshop, they should join at Embedded World. At reInvent. Oh my God! And with Embedded World, and only Embedded World is in my head.
Join us at all the events, right? We are definitely running more of those workshops with our partners and our customers in the future. But reInvent, I think, is the biggest one for us, and we will definitely have something interesting to show there.
And even if you're unable to join one of the live workshops with Thomas with real hardware, the class material is online, and you can just review it yourself and see how it would be like if you actually were able to do it in person.
Okay. Oh, that's very nice. Do you guys have some last words, like some learnings, throughout this process of building the badge project? What did you learn? What is the most interesting takeaway that you learned?
Doing the cloud stuff is really interesting. The hardware to me is easy and fun. Getting the data was trivial, and then I spent the rest of the project learning how all this stuff actually works, learning some new languages and some new environments and techniques. That was a very fun project for that purpose.
I was actually going to say something very similar. We are both engineers, but from two different directions, right? And kind of finding that middle ground and having that good engineering discussion between us. One opinion against another opinion, cloud side versus embedded side, and then figuring out that and landing, I think, at a really nice and entertaining educational product.
Yeah, no, definitely. I mean, I think this different perspective and the learning it's quite interesting, and I think it's good for developers to all have this opportunity of working with an embedded engineer and the cloud engineer and getting different perspectives. So that's really nice. So what advice do you have for our viewers? If they want to get started with ExpressLink, what are the best pages or the best?
So the best page we probably have at the moment is our GitHub repository for IoT ExpressLink. It's really our library of all the support material that we have built so far. It contains the open source manufacturing files for the demo badge. It contains a series of YouTube videos. I'm sure this video will also be a part of that list soon. And we also have the workshop there and other training materials that we have built over the last month. And everything will be in that big library collection. So you can do like a step-by-step learning approach to learn new things, explore, and then also pass on that knowledge to your team.
And not all of that material relies on such a badge. You can use just one of the standard development kits and be very productive with this.
Yeah. All right. Thank you very much. Thanks, Joe. Thanks, Thomas. And our viewers, we are going to be back soon, so stay tuned.